Hello, happy people. This will be our first video for week 3 of virtual learning for pre-calculus. We've been talking about limits, and the last thing we're going to learn about using limits is limits with trig functions. All right, so the first thing we're going to do is we're going to look back at our sine and cosine graph so that we can remember how those values work. So for our sine graph, remember our period is normally 2 pi. In the middle we had pi. Then we had 3 pi over 2. And then we had pi. We went up to 1, down to -1. Sine started at 0, then went to its max, then back to 0, and down to its min, back to 0. So we had a graph that looked like that. And cosine, let's do cosine in purple. Our cosine graph also went to 2 pi. In the middle we had pi, 3 pi over 2 in between, and pi over 2 in between. And we also went to 1 and -1. The difference was, remember, cosine started at its max, went to 0, went to its min, went back to 0, and back up to its max. So the reason we went through and we regraphed these was so that we can look at our values. So today you might have, say, the sine of pi, and you can clearly see, well, my graph isn't so great, but if your graph is hopefully neater, and it's neater on bright space, that the sine of pi is 0. So that would be the purpose of going through and just reminding ourselves what sine and cosine look like. All right, in order to use limits for sine and cosine, we are going to use these two formulas. They can be a bit confusing. I'm going to pause for a second so you can write them down. Pause the video so you can write them down. All right, so they can be a bit confusing for students because it's really the sign of x. As long as it's the same something, then as what's on the denominator, then this limit holds true. So for example, you can have the sign of 7x over 7 and over 7x, and this will still hold true. So it doesn't matter if it's just x, 7x, whatever, that will hold true. Same for cosine here. 1 minus the cosine of x over x will go to 0. We're going to use these two properties today with our examples and in our homework. So we're just going to go through a couple examples. And so here's our first example. We're going to go through several examples, and then we will be done for the day. So our first example is the limit as x goes to 0 of sine squared x of x squared. So what we are going to do is we're going to try to get, since we have the limit of 0 going as x goes to 0 of a sine over x something, we're going to try to get that sine of x over x, or the sine of something over that same something. So I can rewrite this as the limit as x goes to 0 of the sine of x over x times the sine of x over x. Because sine squared of x means sine x times sine x, and x squared means x times x. So if I do that and I take my limit as x goes to 0 of sine x over x is 1, and my limit as sine x over x is 1, so I get 1 times 1. So here my limit as x goes to 0 is 1. So as my x goes to 0, our function is getting closer and closer, but never touching 1. All right, our second example is the limit as x goes to 0 of 4 sine squared x over x squared. So this is a lot like the first example. We're just going to use that the limit as x goes to 0 sine of something over that same something is going to be 1. So I can rewrite this problem as the limit as x goes to 0 of 4 times my sine of x over x times my sine of x over x. So then I just have to plug in my known values for these limits. So my limit as x goes to 0 of 4 is 4. My limit as x goes to 0 of sine of x over x is 1. And my limit of sine as x goes to 0 of sine x over x again is 1. So I get 4 times 1, which is 4. All right, so just changing our equation so that we can see the sine of something over that same something so that we can reduce that to 1 works really well if we're taking the limit as x goes to 0. All right, our third example, something I should have been emphasizing more earlier is we should be double checking if we could just plug in 0. If I did plug in 0 in this equation, I get a 0 in the denominator. So I do have to keep using one of those two properties from before. And for this one, we have the sine of 2x over x. So this is why I was trying to emphasize that it doesn't matter what we're taking the sine of, as long as our denominator matches when we're taking the limit as x goes to 0, it'll go to 1. So here I want my denominator then to be 2x. So what I can do is I can rewrite this as the limit as x goes to 0. And if I want to multiply by a 2 on the bottom to get 2x, I have to multiply by 2 on top as well to get the sine of 2x, 2 sines of 2x. And remember, the reason I have to both multiply on top and bottom is because I'm multiplying by that magical number, which is 1. So now I can rewrite this as the limit as x goes to 0 of 2 times the sine of 2x over 2x. So now that we have the sine of something over that same something, and we're taking the limit as x goes to 0, that limit will go to 1. So I actually get 2 times 1, which is 2. So again, it doesn't matter what we're taking the sine of, as long as the denominator matches when we're taking the limit of as x goes to 0, then it'll reduce down to 1. All right, last example, we're going to take the limit as x goes to 3 pi over 2 of the cosine of x. There's no denominator here, so we should be able to just use direct substitution to figure this out. So if I go ahead and plug that in, I'm going to get the cosecant of 3 pi over 2. And remember, the cosecant is the reciprocal function for sine. So my sine at 3 pi over 2, if we look back at that graph we made, we'll notice it's -1. And the reciprocal of -1 is -1. All right, so we can still use direct substitution with trig functions, which was the whole point of this example. Otherwise, your problems, if you have a denominator that's 0, should be using the sine of x over x or 1 minus the cosine of x over x. All right, I hope this helps you with figuring out limits with trig functions. I hope you are all happy. I hope you're all healthy, and I hope you all have a great day.